Hi everyone, my name is Savannah Tolledo and I am a chemistry and theater double major at Wofford College, and this summer I worked with Dr. Harris in the chemistry department on a project that was the synthesis of an ACAC-derived ligand for the zinc-catalyzed intermolecular hydrogenation of alkenes. I know that's a lot of big words, but let's try to break this down a little bit. So, hydrogenation reactions of alkenes start with an alkene, so a carbon double bound to another carbon reacting with an amine. It's intermolecular because this reaction is happening with two different molecules. Intramolecular hydrogenation, so one molecule with both an alkene and amine, is very widely studied, so trying to do intermolecular was interesting and why we chose to do it. And this is done through the help of a catalyst. It makes something like that. And this catalyst is a metal bound to a ligand, and in the past a bunch of different metals that have been used are things like gold and silver, but the problem with those metals is they're very expensive. So we wanted to work with a zinc catalyst and see if that was going to be just as effective, because hydrogenation reactions, the point of those, they're widely used in the development of pharmaceuticals, agricultural developments, and other industrial processes. So if this can be done cheaper, that would be very helpful. So let's talk a little bit about the ligand, because that's when you get into the meat of my project, because I am trying to synthesize a ligand that has never been actually made before. So the original molecule that I tried to make was this ditosylate. So we have a 5-carbon backbone with 2 nitrogens that are bound to 2 tosyl groups. I tried for weeks to make this molecule and it really wasn't working out, so I switched to the development of what we call a mixed ligand. So right now this is symmetrical, but if we take that tosyl group away and we make it an alkyl group, we get a mixed ligand. And this, I got a lot more progress done when working with this ligand. And the way that I went about trying to make it was through ACAC, so that's why I have that in my title. So ACAC is called acetylacetone. It has 5-carbon backbone with 2 doubly bound oxygens. So you can see that 5-carbon backbone here is very similar to that backbone we have here. And in a few different steps, I was able to possibly make this ligand, or at least make some headway to start making it. So one of the reactions that I did involved using isopropylamine, and that gave me this molecule. And then in something called a Schlinkline, which puts all of the reactions under a nitrogen atmosphere, oxygen is in our air and it's very, very reactive. So it might change our molecule. So if we do a reaction in nitrogen, the reactions that we want to happen will happen without things getting oxidized. So the next reaction I did in a Schlinkline with Meerwin salt and ethanolic ammonia, which turned that oxygen into a amine. And then this guy just stayed the same. And then lastly comes this reaction that actually takes us to what I want to make, and that would be through adding sodium hydride and tosyl chloride, also done under a Schlinkline. But the problem with this reaction is I tried to get to this product in a few different ways, and through a machine called a gas chromatography mass spectrometry, we can pick up different molecular weights on that equipment, and this molecular weight showed up on that instrument, but it came with a lot of different things. It made a lot of other things. And so there's no real way to tell if I made this molecule. I didn't have enough time to isolate it and run more tests to confirm that, but hopefully the next person who takes this project will be able to do that and also just find other ways to make this ligand and run those catalytic reactions that I mentioned at the beginning. If you have any questions about the processes that I went through to make this molecule, please don't hesitate to reach out to me, or anything related to my project at all. Thank you so much.